This conference will now be recorded.
Okay, so now I'm going to help you to understand the DevOps at large, scope for the organization. So, guys, this is a completely theoretical sessions right now, and I would like you to, focus on it, and you must understand the concept of DevOps, because if you do not understand the concept of DevOps, then working with a DevOps tool will be very challenging for you. And this concept everyone must understand. And at the end of it, I'm going to give you an assignment, which everyone has to do it and then submit it. Okay, so please focus on it. Now, understanding the DevOps is very simple. Okay, please do not think you are learning something great, learning something very complicated, learning something which is like only few people can learn. No, it's like everyone can learn. It's a very generic thing. Okay, it's a very cultural generic thing which we should understand. Okay, so look at this slide here. All of you can see my slide right now. All of you. Yeah. So here we have a 5 or 6 parameters. If you look at this on the left side, software platform, setup time. Setup time means here I'm talking about that how much time it takes to set up your software, run a software. For example, you are in college right now. So if I ask you, hey, I need a Windows setup, on top of that Microsoft Office setup, on top of that Java setup. So I will ask you how much time it will take for you to set up if I give you hardware, something like that. So that is a setup time. Now consumptions means how the software clients are consuming applications. Okay, how you were consuming applications. So let's say in my days, if someone say, hey, you go and consume the software, so I'll go to the market, I'll buy a CDs, I'll install the CDs in my laptop, I'll have some serial keys, I buy some, I'll pay the Microsoft or some other vendor like Adobe system in advance. Look at this here, you are paying in advance. The software you are paying in advance. Nowadays, how you are using? You typically you download from the Google, and application is browser based. You can access it like a Gmail. Gmail is a software, right? It's running with a browser. Facebook, you must have tried. I'm damn sure about it. Instagram, you must be using every day, right? So all these are the browser-based applications which you are using. And then we got nowadays, from last few years, the apps has become a trend. Like we install the app in mobile and then use it. So that's consumptions which we are talking about. Now, software delivery means what? Software delivery means how can we deliver the software? How can we deliver? So earlier we were delivering the software in CDs. Nowadays through the internet, we can go and download it. And nowadays you have an app-based, repository-based, and stuff like that also there. Now release cycle means what? Release cycles means how much time basically it is consumed for releasing the software. Now, anyone remember that SDLC cycle? All of you? Anyone remember the SDLC cycle? Can you please comment on it? Which are the SDLC cycle you know, which you have studied in your colleges? All of you? Anyone? So you might have studied this topic, system analysis and design, right? So you have studied some of the release model, right? Some development models, software development model. Anyone remember? No? Guys, are you able to hear me or not? Hello? Yeah, so yes, waterfall model, right? Yeah. So guys, request you to be responsive. Agile model. Yes, agile model. Right. Spiral model, network model, hierarchical model. I think you must have studied. Right now, we are not using those models, but we should know. So yeah, so be responsive, because I tell you, I'm teaching you DevOps, and DevOps is in a simple way, if I say, DevOps is all about sharing our own knowledges, experiences. Okay, so whatever you know, you should share. Whatever I know, I'm going to share. Maybe someone else, also people, those who are also more experienced, they will share their experiences, and we'll share all these experience together, and then we come up with the best solutions so we can develop a software better, faster, and quality software. So that's kind of DevOps. Okay. So here we are talking the release cycle. That means how much time it would take to the release in the market. That means planning the software, developing a software, designing a software, testing the software, and then doing the release. How much time? So if you look at this earlier, used to take a lots of time. Let's say 1 year used to take, 6 months used to take. If you look at the Microsoft release cycle, they used to do the releases once in a year or something like that. Now that I'm talking about, so release cycles from 1 year to 6 months, 6 months to 10 minutes. How can you do that? That's I'm talking about. And then architecture of the software. So architecture here, probably I'll give you little bit of high idea. Architecture means how this software is assembled together. Okay, together. For example, let's say in MS Office, if you look at this, let's say only talk about the MS Word, which you might have used it, MS Excel or PowerPoint. If you look at it very carefully, in PowerPoint itself, you have 200 features actually. 200 features. Remember, bold is one feature, italic is one feature, paragraph H1, H2, and hell lot of features you have. So you see that there's a software and you have 200 features. So now how do you architect the software? So in architecture, there is one architecture, we call it a monolithic. Monolithic means all the functionality, we put it together and we bundle it together and make it one exe in simple way. So you might have installed MS Office in your laptop, or maybe some of you might have installed Java in yours, or maybe some of you might have installed Adobe Photoshop or some Dreamweaver, might have installed some software. So that the software which is you are installing through EXEs, MSIs, and stuff like that, Debian package, RPM packages, this is called monolithic. Monolithic means all the functionality you have in the one package only. So that architecture become a monolithic. But guys, nowadays with the internet, we have a architecture which is SOA. Anyone knows about that SOA? What is this SOA architecture? SOA, service oriented architecture. So from last, when we got the internet, we started accessing the software not through the console, Windows console or Linux console, but we started accessing through the browser actually. Okay, so when we have browser based applications, then we have to change the architecture of the software as well. So then we got a SOA. SOA means service oriented architecture. That means we will set up a web server, which can be Apache, which will set up an app server, which can be Tomcat, and which can be set up a database server, which can be MySQL or MS SQL, whatever it is. So this will be the tier based architecture. That means web tier, app tier, database tier, and stuff like that. So this is called service oriented architecture. So you have web services, database services, app services, like that. But guys, nowadays we are not using the SOA also. You are using microservices. What we are using? Microservices. See, earlier we had a service. Now we have a microservice. I think if I ask you to differentiate between the service and microservice, you will immediately come to know, okay, service is like, okay, we have 50 features over there. Microservices, we have all these 50 features separately developed, tested, and released. Simple. So microservice means all these small. So you want the bold, separate service. You want the italic, separate service. You want to H1, the separate service. And if you look at the Flipkart also, login, separate service. Registration, separate service. Carting, separate service. Payment, separate service. Order history, separate service. So you will have a multiple services, microservices, which is a part of the architecture. Now development model, I think we discussed. We have Waterfall Model, then we got Agile Model, and now we are going to discuss some other models also as part of this called DevOps Model. Okay, so here I hope what I have discussed so far you have understood. So here I'm going to do nothing but helping you to explore the evolution of the software development. Okay, so let's divide into three areas. When we were not having internet, when we got internet, and when we are. So when internet is consuming to us, something like that you can say. So 1990s, we were not having internet. I mean, I'm not talking about that like we never got internet at that time, but I'm saying like at a large scale, users were not accessing the internet. So we were having software platform where we were running application that was a desktop. Okay. Now in 1990s, if I ask you, you have a desktop, remember, you have a desktop or server, physical servers. If I ask you to set up a software, how much time it will take? Probably say, hey, I'm going to procure the hardware, I'm going to install the operating system, I'm going to install the dependent services, and then I'm going to install the applications. So probably it will take a day or something. It may take less also if you have automation. And how we were consuming applications and user consumptions. Still, the laptop is nothing but a console based, the one which we're using right now. So earlier we were using the software like a Photoshop or MS Office and all stuff like that. We were using through the console. So what was the delivery method? How we were delivering the software? Through the CDs. Simple. We were delivering the through software through the CDs, and then what was the release cycle? 1 year. Now the question is why is 1 year? Why they were developing a software in 1 year? Because there is one important element which we have here is, you know what? Think about it. Let's say Microsoft have 1 million customers, and all these customers have installed MS Office. Now all these customers are not connected to each other. When I say connected, that means everyone is the owner of that particular software. Everyone, let's say 1 million people, those who have installed that, they are the owner of the software. That's one advantage, but there's a disadvantage as well. If let's say out of million people, 1,000 people is having software problems. Only 1,000 people are having some problems because of the software. So will it impact other people? No. Only 1,000 people will get impacted. Still, out of million people, 1,000 people is getting impacted because of some issues. So Microsoft will say, hey, because our large user base is not getting impacted, so I don't have to do the release now. I don't have to do the bug fixing now. I will take some time, maybe 1 month, maybe 2 months, maybe 3 months, and so on. So because of that reason, because our users were distributed, users were not connected with each other, users were using the software in an isolated environment in their physical servers, the release cycles become 1 year. The release cycles become 1 year. So they started doing the release in 1 year. Then that is where the monolithic architecture which become popular, because do one thing, because you are doing the releases in the console based applications, the desktop based application releases are 1 year. So let's do one thing, let's assemble all this software together in one package and send it to them for a year. Work is done. So they, scientists who's working in the software industries, software organizations, they saw this is the pattern in 1990s. Okay, they saw this the pattern. So pattern was like you have a physical server, setup time is taking too much, console based application delivering CDs, the release cycle is 1 year, and the architecture is monolithic. So what scientists did, they come up with a solution to develop the software in an effective manner, and that is what they call it model. Okay, so they say, hey, if you can develop a software in any ways, but if you develop software in this way, then you can improve the quality of the software, you can reduce the cost and so on. So at that time in 1990s, the scientists from the software industry, they said, let's do one thing, let's use this model, which is called Waterfall Model. And I'm sure about it. You know that this model, you might have studied in this model in colleges. So this model is become very popular in 1990s. This is the Waterfall Model. You can see that. So here you do the first requirement, and then design, and then implementation, then verification, and then maintenance. So basically here you do in the linear phase, linear wise actually. So you complete the requirement, then move to another phase, then you complete that phase, and then move to another phase. So that way, if you follow this model, the release cycle become 1 year or 6 months. Are you understanding so far, all of you? All of you? Yeah. So that was the 1990s model. Yeah. So that was a 1990 model. Now the question is why we had a model first place. Why we had a model? Oh, this slide you should never forget. Anytime in the future. Okay, this slides is very relevant, and this will be relevant lifetime in your software career. You know, today I'm teaching you DevOps. Tomorrow something else will come. Day after something else will come. Last I learned Waterfall. I learned Agile, and you guys are learning DevOps. Maybe tomorrow you will run. Maybe after a few years you will learn something else. But this slide will not change. Every time we change the model, mind it here. Every time we change the platform, we change the model, we change the architecture, we change the release cycles because of these reasons. Please hardcode these statements. Every organization, those who develop a software, they want to focus on the quality. So last year they did the quality, let's say 80%. They next year they want to deliver 90%, like that. So they want to make sure that how can we always improve the quality of the software, so our users and users should be satisfied all the time. And also they want to make sure that the software should be released very frequently. Why very frequently? Why very frequently? Immediate release of the software. They want to focus. Why they want to focus on the very frequently? Let me tell you guys. Before waterfall model, we had a network and hierarchical model. In that, software used to take software development used to take 4 and 5 years also. Okay, so waterfall model has done improvement a lot. So immediate release of software. Let me give you one simple example. Let me give you a simple example. There is a, I think we all are from India, right? So yeah. So here we have a two app. One is Ola and another one is Uber. Correct? So let's say you are using Ola and Ola app is not accessible for some time. Let's say for 5-10 seconds, and you want to rush for the booking the cab. So what you do? What you do immediately? Yeah, so immediately you will not bother about it. Ola, whether it's what is the problem, you will not, though you are using Ola from last 1 year, you will not show any attachment, and immediately you will migrate to Uber. Next day also, Ola is not accessible just for 10 minutes. The place, the next only for 5 seconds or 10 seconds. Then also you will migrate to Uber. Third time, you know what? Third time you will go to Uber directly, not a Ola. Correct? Is it correct or not? So that's the reason we want the software organization, software company wants the software to be developed and released faster. So if there is a bugs in the software, they can release immediately. So Ola can, if Ola is saying, hey, no, not to worry. I know that what is the bugs which we have. I'll fix next year. You know what you're going to do. I don't have to teach you. I don't have to tell you what you are going to do. The Ola, you know that. So you know what? Ola has to fix the bug, do the releases within a some time, maybe 20 minutes, 30 minutes, whatever the issues what they have to resolve it. Otherwise, they cannot survive in this market. So that's the reason every organizations they want to have immediate release because the feedback of the customer is coming very fast. So they have to resolve it also very fast. Are you understanding that? All of you? All of you? And the third objective for the organization is cost reduction. Let me ask you one simple thing. Remember that earlier days, we used to pay to Microsoft. Microsoft become richer. Why? Because you used to pay to the Microsoft for buying the CD. See, we were not using their software, MS Office or Adobe Photoshop. We were not using it, but we were paying much in advance. Before using itself, you are buying the software. You are paying that money to them. You are buying license fee. So earlier, software companies, organizations, they were getting paid in advance before we consume the software. But let me ask you one thing. Have you ever paid any money for using Instagram, Facebook, LinkedIn, Gmail, Google Drive, WhatsApp? Have you ever paid yatra.com for the comparing the tickets? No. Have you paid for the Google searches? Without a Google searches, you can't survive. Have you paid for the Google Maps? You know that these all apps are so essentials for you. Without that, you will feel I'm dead person. Maybe if we uninstall your apps, WhatsApp, then you will feel like you lost your life actually. Or maybe Instagram. Are you paying for this software? No. So then you will say, hey, Rajesh, I know that I'm not paying for it, but they are making money through the ads. You know how much ads they make, how much money they make from the ads? Remember, think simple, okay? Thousands of people consume their software, only one person clicks on their ads, and that is generating their money for the software organizations. That means, in a simple calculation, organizations like Google or Microsoft or let's say Facebook or Instagram, they need to run software for 1,000 people, out of which only the prospective buyer, prospective customer is only one. Look at this, how much CPU, how much RAM, how much storage they're giving to you, and they need to run the software with 1,000 for 1,000 people, where the customers are only one. Are you understanding? This is the cost to the company. This is the cost to the company. So yes, they are making money from the ads, but also same time, what they want is they want to reduce the software development cost. They want to reduce the software running cost. They develop a software, and for that they hire us software organizations, software buildings, engineers, different amenities. So they want to reduce the software development cost, and on top of it, they want to reduce the running cost also. For example, data center cost, AWS cost, Azure cost, Google Cloud cost, and stuff like that. Are you understanding the problem for the organizations, all of you? Yeah. So yes, guys, no matter which organization you join, no matter which year you work, every time organizations will have this objective. And every time you will have some changes in this. You'll have some changes in this platform, setup time, consumption, delivery, release cycle, architecture, and DevOps, dev model. So you'll have changes. So accept these changes. Okay. So yeah, this was the incident which has happened in 1990s, and we probably I don't know how many of you are comfortable with this 1990s, but I'm from the old school, so I understand all this stuff. Maybe you are from the new school, so probably you just visualize that how much we're struggling with it. And finally, in 2000 onwards, we got the internet to the common people. Though we are having internet before that one also. ARPANET launched the internet in 1974, but actually it got accessible to every people, common people like us and you and me, somewhere in 2000 onwards, right? So finally we got the internet. So guys, when we got the internet, we started accessing application using what? You know that. I don't have to teach you. So you still, I mean, I saw that someone was struggling with the browser also. I don't know why. So you guys should be very pro in that, right? So from last so many years, from last 20 years plus, we are accessing applications through the browser. Yes, we are having our own laptop, but overall, I'm talking about the mass uses of applications, which is happening in your life, is through the browser. Agree with me or not? Not now. I'm talking about 2000. You have to come back little. You have to go back a little bit, early in your days. Agree with me? All of you? All of you? Hello? Yeah. So now the question is, please remember these slides. I'm not going to let you forget these slides actually. This is very much important slides. So guys, when you have internet and when people are accessing the internet software using the browser, then we need to reduce the cost, guys. We need to reduce the cost. So earlier, the software we were running in a data center in a physical service. That was a very costly. Then what we did, software organization, they migrated to virtual server. Virtual server. Yes, they migrated to virtual server. So now the question you may have in your mind, some of you, what is the difference between physical server and virtual server? Can you please take a note of it? These questions you have to do offline study. If you don't know, then you have to do study. If you know that question's answer already, wonderful. You are at the good speed actually. So virtual server. By the way, the machine which you access Linux inside of some boxes, that is also virtual server. That was run by virtual. That was run by virtual box. That was also virtual server. So here in 2001 onwards, when wanted to reduce the running cost, software running cost in a data center, then instead of using the physical server, we started using the virtual server. Wonderful. And now you know what? When you use the virtual server to set up any software, it just take 5 minutes. You go to AWS, get a virtual server. Go to Azure, get a virtual server. Go to Google Cloud, get a virtual server. You are accessing the virtual server right now in your lab environment. So how much time it takes to set up virtual servers? 5 minutes probably. So how we were using the software? Browser. And now how we are delivering the software? Because we have internet, you can download from the internet and you can consume it. So this is the model which we followed in 2001. So we got the release cycle 2 weeks. Why we got the release cycle 2 weeks? See, if there is a problem in the software, let's say you were using in 2001 words, we were using Orkut. I don't know how many of you have used Orkut. I use Orkut. Okay, and in fact, I use a lot. So that was one of my favorite time pass in office. Right? And I later on I repented a lot. I wasted so much of time on Orkut. They removed the software altogether. So we were using the application based out on the browser. So when it's based out on the browser, because see here your end user, think about the end user. Think about the end user. End user are using same software. See earlier, let's say Microsoft is selling me 1 million licenses of MS Office. All their customers are distributed, scattered, not connected together. But now, let's say you're using Orkut or Facebook or Google searches or Google Map, or for the sake of any software like a Redis, they are still using same software. No matter whether the traffic is coming, the users 1,000 or 1 million or 1 billion, they are still using the one software. Here you don't have a multiple software. Are you understanding, all of you? That means I am using the same Facebook what you are using, and you are using the same Facebook what others are using. So if Facebook is having some problem, because Facebook is also software, right? Then we all get impacted. Don't you think so? All of you? Simple. So what they did, the scientists said, hey, we need to reduce the release cycle. We have to do something. So they migrated to the virtual machine, physical server to virtual machines. They migrated to the release cycle for 2 weeks. Then they suggested, hey, let's do one thing. Let's change the architecture also, software architecture. So instead of monolithic, let's do the SOA, service-oriented architecture. Keep it separate server, web server, keep it web application server separate, keep it database server separate, and all these things, blah, blah, blah changes has made it in the SOA. So scientists suggested, let's do this one. And after that, they suggested Agile. And Agile is the same one which someone said just 10 minutes before. So guys, I'm going to have 5 volunteers in this room. And can you please tell me, can you please define Agile in your terminology, whatever you learn? You may see, don't worry about this rightness of the statement. I mean, you may be wrong, you may be right, but you have to share. That's the culture in DevOps. So what do you think? What is Agile as per your learning process? Anyone would like to share with me? Okay. Anyone else would like to add something on top of it? Please feel free to share, because DevOps is all about sharing. Please understand that. It's all about sharing, nothing else. Please share your knowledge. Yeah. Anyone else would like to add something else? Yeah. Yeah. Good. Great. So guys, I'll tell you in my word. Okay. Let me share my experience with you. To be honest, whatever you said, it's the same thing I studied also in my colleges. Okay. But honestly speaking, I never understood that those terminologies. Never understood. Though I did Ratamara and sort of things, and then I could tell you also at that time also. But what I understood while working with an organization is very simple thing. It's very simple thing, easy to understand, but we simply complicate that with the keywords. See, I'll tell you one thing. If I ask you to develop a software with a 10 features, then let's say estimation time is 1 month, or let's say 6 months. I'll say, hey, you guys develop a software for me, and you have a 10 features in the software, and how much time it should be delivered? 6 months. Okay. So that is a standard ETA for it. ETA means that's a standard timeline for it. Now, if I ask you to develop that same software instead of 6 months in a 6 weeks, 6 weeks or 6 days, can you do that? No, it's not possible. It's not possible because the standard timeline deadline for developing that 10 feature all exclusive together is 6 months, which we no one can deny on that. So what to do? So here what we are saying, hey, listen, in SOA what we are saying, in Agile what we are saying, listen, don't plan for 6 months. Simple formula. Don't deliver the software at the end of 6 months. Because if you deliver all the functionality of all the software in a 6 month, that's a waterfall model you have to select. So 1 month you plan, 1 month you design, 1 month you code, 1 month you test, 1 month you release. So all together it may become a 6 month. But here we are changing the approach. We are saying, hey, I know that 10 features to develop it takes 6 months by these people. We will not develop all features in one go. We don't want to release it in one go. What we want is do one thing. Instead of developing a 10 feature in 6 months, or let's say to random make it, let's make it 10 feature in 10 months to make it random. Don't give me the complete product at the end of 10 months. Rather than what you give me is only one feature in 1 month. Yes, only one feature in 1 month, or only one feature in 2 weeks, or only one feature in 1 week, like that. So what we did, nothing else. Earlier we were delivering the software in one go. That's waterfall model. In Agile model, what we did is we divided that huge task into smaller tasks, and we reduced the release cycles. So Agile means what? Agile means instead of delivering the whole software, delivering the part of the software to the release, to the customer. So that's called Agile. In Agile, what we do, in waterfall model, what we do, developments and testing team used to work in an isolated environment. Isolated environment. Development team is somewhere else, sitting in some different locations, on different team, and testing team is some different teams actually altogether. But in Agile, what we did, we brought this team together. In Agile team, what we say, hey, dev team, those who write a code, and testing team, those who test the software, should be in a one team only. So the collaboration got increased, and we started saying, hey, it's Agile team, and instead of releasing the software in 6 months, we have to do the release in 2 weeks or 1 week or 3 weeks or something like that. So now you understood what is Agile? Yeah. Now, so see here how we are improving desktop to virtual machines, saving lots of cost, set up 1 day to 5 minutes, wonderful, consumption console to browser, CDs to download method, release cycle 1 year to reduce to 2 weeks. We did not do anything great. We just minimize the work actually. Okay, we minimize the work. Architecture monitoring to SOA, and development model, we changed from Waterfall to Agile. And you know what? This was a very popular model which you used in 2000 onwards. Okay. So far you understood, all of you? Yeah. So this is the image, which is a perfect image. You can see this is Agile model image. So here all the teams coming together, working together, and having a target of 1 to 4 weeks of sprint. And in that target, they do work on the specific backlog only, not everything. They decide, okay, we'll work on this week, this sprint, we'll work on this number of tasks only, and we'll deliver to the end user. We'll deliver to customer, and then we'll start taking up more work from the backlog, and we'll keep working on like that. So here, instead of waiting, the customer, see here what will happen. Frequent, you get a feedback about it. So instead of the customer is getting heart attack at the end of 1 year, you are saying, okay, as a software engineer, we'll give the heart attack every second week. Okay, though it's just a funny statement, but it's like delivering the software to the customer every second week. That's called Agile. Are you understanding, all of you? Yeah. So this is how we evolve. Same reason, guys, why we evolve, why change ourselves, why we change ourselves. This is the same reason all the time. Organizations always have this objective in their mindset. Please hardcore. So next year or after a few years, if you get into the different trainings altogether, they have a same reason actually. Okay, but they will change the model, architecture, tooling system, and platforms. So now, guys, how we are consuming application now, I don't have to teach you, because you guys are from the current COVID batch. We say COVID batch, right? So how you guys are using application software? So remind yourselves, how many of you have accessed the laptop for consuming the software? I'm not saying, hey, you want to study, so you open up your laptop. I'm not saying that one. I'm talking about the end user consumptions. How much time in last 2 years you've been working from home most of the time? How did you consume the software? And I think you will say, everyone, mobile, right? Am I wrong? So mobile, what you want to access? WhatsApp, Instagram, Facebook. What else? Do we have any other software? Any other software which you guys have consumed from last 2 years? Google searches, Google Map. What else? Google, Gmail. What else? Maybe slides, Google Slides, Google Doc. What else? If you guys have accounts, SDFC Bank from mobile, UPI, yes, UPI, right? Paytm, Karo, and GPay and Phone Pay, correct? All these things, correct? Na? So how did you use that? How do you consume? So you have consumed through mobile. So guys, we are changing from the browser to mobile devices, and this is how we are consuming. So this is the world of today's now. So think about it. See, don't you think we all are connected now? We all are using same software. Same software. Same software. We all are using same Facebook, Instagram, TikTok, which is banned in India right now. And what do you say? Other application like SDFC Bank, only one software. ICICI Bank. Yes, see, you guys are great. Yeah. See, when I consume Netflix, I forgot that. Prime, Netflix, Amazon.com, Flipkart.com. So if you look at this today's trend, we all are using the same software actually, and we all are connected. How? Because you are also using the same Netflix. I am also using the same Netflix. There's no two Netflix. Simple. So Netflix is also a software organization. It's a software. It's a software organization. So they need to do something, right? they need to improve the quality of the software. They need to improve the quality of the software. Because you know what? Let's imagine if Flipkart is down for 5 minutes, just imagine how much of business losses, business transaction losses they will bear it. Only for 5 minutes. Just imagine. Only for 5 minutes. Branding will be going for the toss. Branding will be compromised. Their marketing strategy will be compromised. Their customers will feel frustrated. Some of them will have a frustration with the payment gateway. Some of the people have ordered it but not received it. So much issues they will get it if the quality of the software is not good. On top of that, they need to reduce the software development cost and software running cost because you are not paying for it. You are not paying for it. Let's say YouTube. Just imagine YouTube. I'm damn sure about it. At least 1 hour you must be spending on YouTube. I am spending more than that value. Okay. So how much money you are paying for watching the videos, content, and all? No, nothing. So they are making money from ads. That's true. But at the same time, they cannot be profitable if they will not reduce the development cost and they will not reduce the running cost. Trust me on it. So they have to do that cost reduction. And they also need to reduce the release cycle speed of the release. So they want to bring it. The organizations wants to bring it by looking at the latest technology and stuff like that. So again, same statement, guys. What to do? What organizations should do to improve the quality of the software, to get the immediate release of the software, and to get the immediate to the cost reduction in the software development and runtime. What they need to do? So guys, they need to do lots of things. Lots of things they need to implement, and then only it can be possible. So the latest trend in the software consumption is we all are connected to the same software, one version of software. Everyone is connected together, and the expectations from the end user is 24/7. It should be up and running without even single second of downtime. Single second of downtime. Let's say if you have a Prime down for 5 minutes, forget about the 5 minutes, 1 minute. A Facebook down for 1 minute is become a headline for the world actually. Facebook is down for 1 minute, 60 seconds. Why? Because we are not expecting any downtime. Correct? Huh? Are you understanding that expectation from the end user? So guys, now you are a software engineer. You know, you are a software engineer now. Forget about the end user now. You are a software engineer for your organizations. Organizations has the objective to reduce the cost, improve the quality, and reduce the release cycles, durations, and all stuff like that. You as a software engineer, you have to change the stuff which is required to get it done in the software development. What are the things you're going to change? So guys, let me tell you here is very simple way. You are a software engineer for this generation, and if you want to reduce the cost further, then you have to migrate from the virtual machines to container. Now, next question you may have, what is the container? Anyways, I'll teach you as part of the Docker sessions. But yes, this is the migration needed. If you really want to be a software engineer, you need to know containers. Same way, can you be a software engineer without knowing the laptops in your college days? Each one of you must be having laptops. And without a laptop, can you work? And without knowing the laptops, how to use operating system, browser, this, that, and stuff like that, can you work? No. So yes, nowadays in today's this era, you have to run an application not in your laptop. You have to run an application not in a virtual machine, but you have to run applications in the container. So you should know what is container. Yes. If you don't know, and if you don't know now, today, or maybe next 6 months or next 1 year, then you cannot be a software engineer for sure. Because the market demands, if you want to run software, you have to run in a container. Why? because we want to reduce the software running cost. So all of you have a right expectation set, what you need to know to become a software engineer. All of you? All of you? Yes. So guys, setup time, how much? Please read it. It's 1 second. That means I'll put it in a very simple way. I'll say, hey buddy, can you install application which has a hell lot of complexity, dev server, app server, database server, app server, web server, this direction, that direction, hell lot of things you have it. But I will give you the time only 1 second. Can you do that? If you can't do that, then how can you be a software engineer? Simple. Because earlier in a laptop, you used to take 1 day of setup time. Then with the VMs, we reduce the time for maybe 5 minutes. But in a container worlds, the setup time has been reduced to 1 second. If you can't run your application in 1 second, the complex application in 1 second, then how can you become a software engineer? No, in today's world, I'm talking about this year. So if you cannot run your application in 1 second, you cannot be a software engineer. So you need to know how can we run our application in 1 second. How we are consuming applications, we know that. How we delivering the applications. So we have a stores like app stores, play stores, and I'm sure you must be using a lot, because I'm using very less those stores because I don't want to install too many apps from the store, but only useful apps. But you must be an expert in that. And look at the release cycle. A release cycle should be only 1 hour. See here. So here what I'm expecting here from all of you. This is just for Notion, okay? Earlier, we used to plan in 1990s, we used to plan, design, code, test, and deliver the software in 1 year. Then we reduced that to the Agile, we reduced to 2 weeks. Now we have to do in 1 hour. Is it possible? If it is not possible, then you cannot be a software engineer in 2021 onwards. Okay, so guys, we have to change the architecture also. You need to know architecture also, and that you need to know microservices. Yes. So you need to know what is microservices. Why do we need a microservices? What are the principles of microservices? What are the practices of microservices? What are the benefit of the microservices? How can you change the architecture of the software from the monolithic to SOA and SOA to microservices? You should know software development using microservices, not SOA and monolithic. And if you don't know, then how can you be a software engineer in 2020s? And last one, guys, overall, how can you bring overall changes? How can you bring overall changes for doing all to bringing all these evolutions? So that concept is DevOps. Are you understanding now? So DevOps will bring what? So DevOps will bring certain, please hear me out. I'm not teaching you DevOps right now, but helping you to visualize. DevOps is the keyword actually, it's a wrapper. DevOps will bring many changes in your team. I'm saying team, software development team. DevOps will help you to bring evolution from the virtual server to containerization, reducing the setup time to 1 second, release cycles to 1 hour through the microservices concept, bringing lots of changes in terms of tool set, practices, process, mindset, culture in your team. Many things it will change it. And why we are doing this DevOps now? We are doing DevOps the same objective, guys. I will again and again, I'll show you same objective. this one. So have you understood the evolution of DevOps, how we are evolving over the period of time, and what are the objective of the DevOps? All of you? Yes. So guys, you need to know now what is container. You need to know what is a microservices. You need to know what is DevOps, which I have not taught you. If you think I have taught you DevOps, no, I have not taught you. The practices and process is still pending. You need to know what is CI/CD. You need to know what is SRE. You need to know what is DevSecOps. You need to know all these things. Some of these technology I'll teach you as part of this session. For example, I have a planned Docker session in which I'll teach you what is container. I have a plan for DevOps, which I'll teach you. I have a plan for DevSecOps, which is the last topic, which I'll teach you anyway. So DevSecOps discussions will do that tomorrow. Okay. But today I'll teach you what is DevOps. So guys, do let me know how many of you have understood the evolution of our changes over the period of time, and are you ready to adopt these changes? Are you ready to run application in a container, setup time in one applications you should be developed, the release cycle should be done in 1 hour with the help of microservices concept and through the DevOps culture. Are you understanding that? Can you please confirm in the chat window, all of you? How many of you have understood? In the chat window, can you please confirm me? I just want to count it. Great. So guys, so now we will have a little bit of rapid fire. So let's get started. So what is the DevOps? Let's understand this. What is the DevOps? So guys, in the regular general practices, what we say, our objective R means objective of the project. Okay, don't think for yourself. Okay, when you're a software engineer, okay, don't think anything for yourself only, think for a team. So tell me one thing, if there is a one objective, then there should be one team or there should be 10 teams for that. Tell me, which is a good practice? Team, I'm talking about team. One team is good or 10 teams are good? All of you? For one objective, one goal? Yeah. So here you think about it. You know what? Waterfall model, if you look at it carefully, Waterfall model has created multiple teams actually. Remember, one software, multiple team. So development team, architect team. See, there was a model. I'll show you this one. Probably you'll recall this. Go to that image. See here. So requirement team, one team, design team, one other team, implementation team, one team, verification team, one team, maintenance team, one team. So requirement typically we say architect, design, we call it design and development is by the coder, developers, engineers. Verification maybe testing team, maintenance means operations team. So here in the waterfall model, what has happened? They created a multiple team for one objective. So that's the reason they were able to deliver the software in 1 year. But you know what? In Agile model, what we did, in Agile model, we brought it together, development and QA team. Yes, brought it together, development and QA team, and saying that, hey, you guys are not a development and QA team, you guys are Agile team. Agree with me, all of you? Hello? Yeah. So now guys, you know what? See, what is the problem with the multiple team? What is the problem with multiple team? So the multiple teams, if you have a one objective, and if you have a multiple teams, then you know what? Multiple teams means multiple, simple way I'm telling you, multiple politics. Yes, multiple politics. One team means no politics. Multiple team means multiple politics. Multiple tool set, multiple culture, multiple processes, multiple boundaries. So, so what will happen when you have one goal, multiple team, multiple mindset, multiple culture, multiple tool set, multiple process, multiple practices? Then release cycle of course will get delayed. Release cycle of course will get delayed because these are the team. They are talking, integrating in their own way. So the release cycle will become delayed. But we want to reduce the release cycle. So what we did in Agile, what has happened? Engineering team, development team, and QA team, we brought it together, and we started calling it Agile team. But in today's world, when we want to reduce the release cycle more, improve the quality of more, reduce the release cycle and improve the quality, then what we need to do is we need to merge the development and operations team together also. Because here in today's world, we have an engineering team and operations team. Operations team, those who are taking care of the infrastructure and production boxes and pre-production boxes. And development team, those who are developing the software and validating the software. So there is a huge gap between these two in today's world. Huge gap. Who created this gap? Agile process. Agile process brought something where you divide this divided into two teams now. Earlier there were multiple teams such, but now with Agile we got a two team. But now we want to reduce the release cycles also from the 2 weeks to 1 hour. So many things has to be done, but this one thing which is very important, you have to merge and make it one team now. Okay. So here you see that. Hi, I'm Mark and I work in the development team. Hi, I'm Linda and I work in the operations team. So here you see that two teams are there. And these two teams is creating a wall between them. Because development team have no understanding of operations team and operations team have no understanding of development team. So they fill there's a gap between these two people. And because of this gap, the quality of the software is getting compromised, release duration is getting compromised, and lots of problems which occurred because of this gap. Operations team and development team. So what do we need to do? Can we ask them to work together? Earlier, they were fighting with each other. There were two opposite camps, developer and operations. Developer's behavior is little different, operation behavior is little different. But now, both the team, we have made it together as part of the DevOps adoption. So in a simple way, if I say, if you really want to implement the DevOps in your project, please do not have a multiple team. Let's have it one team and you call it a DevOps team. They will work together. So see here, the moment you merge the teams together, will become a single mindset with a single right tool set and a single roadmap for the change. Are you understanding? All of you? All of you? So this is the changes we need to do. See, when you are behaving like a developer, your mindset will be different. Your culture will be different. When you're working at the operations, your mindset will be different. Your culture will be different. We need to fill this gap for DevOps. Okay, so this is we discussed this one. What organizations want, we discuss this one. This is the challenge what every organizations have. In this image, if you see one project, you have a multiple teams, multiple mindset, multiple processes, multiple politics. So there's some background noise coming from someone. Mute yourself. Yeah. So if you have a here if you see the development team, QA team, operations team, this team, that team. So multiple teams, multiple mindsets, multiple challenges, so like multiple integrations, delayed integrations that will bring the delayed in the release and quality of the software, reduce the software quality. So what we want to do? What we want to do? Challenges of IT organizations. Every organization, what they want to do, they want to have a very easy integration between the multiple teams so they can develop a software with a quality, with a reduced cost and stuff like that. They want to integrate multiple tools also. See, different teams are different people are using different tools. Ops team has a different tools, development team has a different tools. They want to integrate multiple minds, multiple culture and mindsets you have, multiple processes you have, multiple practices we have, multiple SDLC cycle phases we have. We want to integrate. That's a challenge for the organizations. That's a challenge for the organizations. Multiple teams, multiple integration, multiple processes, multiple practices, multiple tool set, multiple mindsets. This for only one goal, which is making challenges for the organizations. So how do they solve it? How do they solve it? See here, you have multiple teams in a software organization: analysis team, design team, development team, testing team, development and maintenance team. Okay. See here, operations team, quality assurance team, and development team. If all these team will not work together, mind it here, if all the teams will not work together, how can you reduce the cost of the production? How can you improve the quality? How can you reduce the release cycles? That's a challenge for the organizations. See here, multiple tools. Different teams are using different tools. If you see, version control tools, build tools, compile tool, packaging tool, operations tools, test tool, publishing tools. These are not integrated together, which is, consuming lots of time for the integrations. Multiple SDLC cycles. So different teams follow their own cycles, which complicate the things. So integrations also become a challenge from the planning to coding, coding to build, build to test, test to deploy, deploy to operate, operate to monitor. You see the planning phase, different tools, coding phase, different tools, building phase, different tools, testing phase, different tools, deployment phase, different tools, operation, different tools, monitoring, different tools. Integration become a challenge. You see that here, tool sets, multiple tool sets during the phases, plan, develop, build, package, test, release, configurations, and monitoring. Multiple tools are there. How can we integrate all this thing? How can we integrate all these things? Look at this. If you join your project, these are the tools will be there, which you can see, most of you. So many tools are there. For one problem, there is one tool. How can we integrate all these tools together? So there's so much of challenges. You saw that, right? What was the challenge? Challenges for organization. Multiple teams, multiple processes, multiple practices, multiple tool sets, multiple mindsets. People have different processes in their own team and stuff like that. So organizations want to improve the quality, immediate release, and cost reduction, where you have so many challenges. So what they should do, how this organization can do the changes which we discussed earlier. How can you do that? So did you understand the problems, all of you, of the organization? Oh, yeah. So what is the solution? Solution is DevOps. See here, look at this image very carefully. Solution is DevOps. So we migrated to over Waterfall Model to Agile, and you know that why we migrated and how what you did in the migrations. So in the Waterfall Model, you had a multiple teams. In Agile Model, we made it together, a development team and testing team together, and operations team we left it as it is. But in a DevOps model, what we are saying, hey, let's bring all these people together in one team. That means development, testing, and operations will become one team, and we call it a DevOps approach. What we call it? DevOps approach. Okay. So as part of this DevOps implementation, requirement changes frequently. Development team needs to be agile, and also operations team need to be agile. And how can they be agile? They have to become one team only, so they can understand all the development challenges, they can understand the operation challenges, they can work together and solve the problem. And then release requirement change frequently means release can happen frequently as you need it. So if Ola is down for 10 minutes, they will immediately fix it within a 10 minutes. While working together, all these teams working together, immediately they will fix it, and then Ola is again back to the running state, or Uber, or HDFC Bank, ICICI Bank, or whatever the software you're using. Are you understanding now, all of you? Why the DevOps is so important? DevOps will bring all the teams at one platform so they can work together in an integrated environment. So you have to merge the team, you have to integrate team, you have to integrate processes, you have to integrate practices, you have to integrate culture of the team, you have to integrate the mindset, you have to integrate tool set, everything you have to integrate, and only one team now. That's what DevOps team. They will work together for any challenges which you get it, and they will deliver as a team, not as a multiple team. It's not like okay, development is team has completed the work, but testing team has not completed the work, or operations has not completed the work. It's not like that. There's no multiple team in a DevOps approach. So here, mind it, Waterfall is a model, Agile is a model, DevOps is an approach for doing the things in a to reach the organization goal. Are you understanding, all of you? So this is a DevOps. Again, we'll keep discussing more the DevOps. Okay. So if you think you have understood the DevOps, no. We need to know a little bit more about it. You need to know a little bit more about it. What is the DevOps? Okay. So these discussions will take it up after the break, lunch break, and get going. So guys, before